Hi, welcome to class. My name is Don LaFon, Professor Don, and this week in Cisco 2, we are covering Module 4 Inter-VLAN routing. If you are watching this live with me right now, then I encourage you to hold your questions until the end of the presentation, and I'll give you a question and answer period where you can ask away. If you are watching this as a recording inside of NetAcad, please ask your questions inside our help discussion forum, and your fellow students and I will help. And if you're watching this on YouTube, please ask questions down below in the comments, and I encourage you to help each other out, even out on YouTube, because you will be a better community if you do. I'm going to go ahead and get started by sharing my screen. And then I have to start it. And one more thing I have to do here. All right, Module 4, Inter-VLAN routing. The objective is to troubleshoot inter-VLAN routing on layer 3 switches. First, we have to learn enough about inter-VLAN routing. So we're going to start off with describing options for configuring inter-VLAN routing. We'll configure router on a stick, inter-VLAN routing. We'll configure inter-VLAN routing using layer 3 switch, and we'll troubleshoot common inter-VLAN configuration issues. All right, so last week we learned all about VLANs, and we learned that VLANs allow us to segment a network logically. So, for example, here in this, let me zoom in a little bit so you can see it better. In this layout, we have 3 different floors, but instead of having a physical layout where this switch is layer floor 1 switch, floor 2 switch, floor 3 switch, we actually have different computers on each floor. So VLAN 2, for example, includes computers on each floor, and that's not unusual in a corporation. In a corporation, you could, for example, in our classroom, we could have a instructor. We always have an instructor in each one of our classrooms, and we have students, regardless of where that class is. So, what floor the classroom is. So it's important to be able to logically divide up a network. In this case, we have these 3 switches. These 3 hosts all on different on VLAN 2. These 3 hosts on VLAN 3 and VLAN 4 here, even though we have switched. Now, last week, all we dealt with was talking through the switch back to another host. One host, for example, this host could talk to this host through a switch, no problem. But what happens if this host wants to talk to that host, right? It can't, it's on a different VLAN. It can't communicate. It's the whole purpose of VLANs, right? Dividing them up. It can't talk to it. So what it has to do is it actually has to go all the way out to the router and then come back, and then it's able to get out there. That is router on a stick. Now I'm going to show you in a minute the old way we did it with legacy, but good news is you don't have to configure legacy anymore. You just have to know about it. But how do we talk from this host on VLAN 4 to this host on VLAN 2? That is today's presentation. VLANs are mutually isolated, and packets can only pass between VLANs via a router. Now, VLANs are split into 2 categories. There's the normal range VLANs. They are VLANs 1 through 1005. The configurations are stored in the VLAN.dat in flash memory. IDs 2 through 102 through 105 are reserved for legacy token, and they're no longer supported. and 1 is also the default VLAN, and so 1 is actually not configurable. It will always be the 1 default. So there's 5 you can't use. That allows 2 through 1001, and that gives you 999 VLANs in the normal range. Now, there are also VLANs in the extended range, 1006 to 4096, and those are used from the system, the network, in a way. Those configurations are stored in running configuration, and we learned last week about VTP and how VTP allows switches to send and receive VLAN information between each other. VTP does not learn about extended VLANs. And again, when you turn off the computer, those VLANs go away. So what is inter-VLAN routing? Well, I already told you the concept, but VLANs are used to segment layer 2 switch networks for a variety of reasons. Regardless of the reason, hosts in one VLAN cannot communicate with hosts in another VLAN unless there is a router or a layer 3 switch to provide routing services. Inter-VLAN routing is the process of forwarding network traffic from one VLAN, VLAN 2 or 20, to another VLAN, VLAN 3 or 30. There are 3 inter-VLAN routing options. You can have legacy inter-VLAN routing. This is a legacy solution and it doesn't scale well. Literally, you have to run so much more Ethernet cable to make legacy inter-VLAN routing work, and the routers have to have more ports. It doesn't work. Maybe if you have a small office with just a couple of VLANs, it'd be fine, but not in the production world of small and medium-sized business, probably not. Router on a stick, that's what we learned now. This is an acceptable solution for a small and medium-sized network. And then layer 3 switch using switch virtual interfaces, SVIs. This is the most scalable solution for medium to large organizations. Let's look at inter-VLAN routing. So legacy inter-VLAN routing, which was the first inter-VLAN routing solution, relied on using a router with multiple Ethernet interfaces. Each router interface was connected to a switch port in different VLANs. The router interface served as the default gateway to the local hosts on the VLAN subnet. Legacy inter-VLAN routing used physical interfaces. It works, but it has a significant limitation. It is not reasonably scalable because routers have a limited number of physical ports. Remember, you can have 999 VLANs. Now, you're probably not going to have that many VLANs, but let's say you have 10. You literally would have to have 10 ports on the router, with each one having its own default gateway to the switch, which then would have to have 10 ports used just to go to the router for your different VLANs to be able to get to each other. So VLAN 20 literally goes up its own network to default gateway. Notice the 20, right, in the 20 network, and then the router routes it to the 10 network, and then it comes down to PC1. This method of inter-VLAN routing is no longer implemented in switch networks, and it is included for to explain the concept only, and is no longer configured in this course. But I wanted you to see that it is not that challenging. It's pretty easy. You basically are just setting your VLANs on the ports, right? And then you are setting your IP addresses on the interface to the router, and you are done. It's not that hard. The only reason it's confusing is because it confuses you when you go to use router on a stick, because they're two different things, and you have to understand router on a stick. So you saw it, now forget it, okay? Router on a stick inter-VLAN routing. So the router on a stick inter-VLAN routing method overcomes the limitation of the legacy inter-VLAN routing method. It only requires one physical Ethernet interface to route traffic between multiple VLANs on a network. A router's Ethernet interface is configured as an 802.1q interface, and it's connected to a trunk port on the layer 2 switch. Now, I want to point out, and this was confusing to me when I went through the course, and I don't, right at the beginning, I do not want you guys to be confused. If you're on a switch and you have traffic that's from multiple VLANs, or the potential to have traffic from multiple VLANs, even if one's just the native VLAN and you have one VLAN for everything else, then it is a trunk port on a switch. Now, routers do not have trunk ports. This interface does have to be configured, but it is not a trunk port. The trunk ports allow for multiple traffic to run between switches, and even leaving the S1 here and heading to the router, you have multiple traffic on that port. So you have to
Can't hear you.
Okay. Sorry about that. I mentioned earlier that I do have a problem with sound going out, and we're not quite sure what's creating that. Yeah. Okay. Note to self, turn off volume on cell phone. Anyways, let's just keep moving. You do have to configure R1's interface here. You have to bring it up, obviously, and you have to configure sub interfaces, and each one of the sub interfaces goes to one of the one of the VLANs, and we will learn about that as we move through. Let's read what it has here. Let's see, it only requires one physical. A router Ethernet interface is configured as an 802.1q interface and configured to a trunk port on a layer 2 switch. Sub-interfaces are configured in the software on the router to identify the routable VLANs. The configured sub-interfaces are software-based virtual interfaces. Each is associated with a single physical Ethernet interface. So the router on a stick approach uses only one of the router's physical interfaces instead of one for every VLAN. One of the router's physical interfaces is configured as an 802.1q trunk port, so it can understand VLAN tags. It's not configured as a trunk, though. It's just configured as a trunk port. Logical interfaces are created, one sub-interface per VLAN. Each sub-interface is configured with an IP address from the VLAN it represents. VLAN members, hosts, are configured to use the sub-interface address as the default gateway for the router. So let me zoom in on this. And so here we have all our trunks set. There should be another trunk here, by the way. I'm sorry, there should be another trunk here. Here we set our sub interfaces, and we have to actually configure all of the switch ports. So here they're just showing S2 right here. So on FO11, this guy here is in the 10 network, right? So you configure this port to be VLAN 10, and then you configure this port to be VLAN 20. It goes to the 20 network, and then you configure this port, the FO23, to go to the 30 network. So there's your access port configuration that you learned about last week. These are all need to be configured. These need to be configured all as trunk ports. Remember, with the VLAN allowed and making sure you have the same native VLAN on both sides. And then this is also configured with the FO3 here on switch 1 is also configured as a trunk, and it has to have all the VLANs that are going to transfer out to R1. In this case, it would be 10, 20, and 30. Okay, so you get the concept. That's what we're going to configure. Router on a stick Inter-VLAN routing. In this example, the R1 interface is configured as a trunk link and connects to the trunk F03 port on S1. Router accepts the VLAN TAC traffic on the trunk interface. The router internally routes between the VLANs using the sub interfaces, and then router then forwards the routed traffic as VLAN tag traffic for the destination VLAN out the trunk link. Okay, hopefully that helps you to understand with a little graphic. Note, the router on a stick method of Inter-VLAN routing does not scale well beyond 50 VLANs. I think 50 VLANs is a lot of VLANs, and you probably won't run into that in a small or medium-sized network. Router on a stick scenario. In the figure, R1's gigabit 0/0/1 interface is connected to the S1 fast Ethernet 0/5 port. The S1 Ethernet 01 port is connected to S2 fast Ethernet S1. Wow, this is confusing. These are trunk links that are required to forward traffic between the VLANs. So this is a trunk link, this is a trunk link, this is a trunk link. That is not a trunk link. Even though it says trunk link, it's only configured as a trunk here. On this side, you configure it the sub interfaces. To route between VLANs, the R1 gigabit 0/0/1 interface is logically divided into 3 sub interfaces that you see here, as shown in the table. The table also shows the 3 VLANs that will be configured on the switches. Assume that R1, S1, and S2 have initial basic configuration. Currently, PC1 and PC2 cannot ping each other. PC1 cannot talk to PC2 because they are on different VLANs. They're in VLAN 10 and 20, right? So only S1 and S2 can ping each other. So these two can ping each other, but they are unreachable by PC1 or PC2 because they are also on different networks. So they're talking about this guy can't talk to that guy. Actually, this guy is on 9. These two can because they're both on the 9. It looks like they're both on the 99 network, maybe. I don't think so. It's a weird configuration for a network with 4 ports to have /24. But anyways, to enable devices to ping each other, the switches must be configured with VLANs and trunking, and the router must be configured for Inter-VLAN routing. So this is the configuration. So the first step is to create and name the VLANs on the switch. Then you create the management interface. You configure the access ports going to the PCs, and then you configure the trunk ports. So we're dealing with this network here, and we configure VLAN name 10. I like the fact that they go, you actually don't need to type exit. You don't need to type exit. You can do VLAN 10 name LAN 10, VLAN 20, name LAN 20, VLAN 30. Well, they have VLAN 99. There's no VLAN 30. But you don't need to type exit to get out just to go back into VLAN sub-configuration mode. You guys may know that already. Notice they set their management interface to 99. Then they go to the switch and they set a SVI, a switch virtual interface, to be able to manage the port remotely. Remember, switches generally don't have IP addresses, only routers do, unless you want to manage it remotely, and then you have to give it an IP address so it's reachable. And you type, and you have to give it a default gateway so it's reachable from outside of the network, and bring those ports up by saying no shutdown. Remember any port going to F018, this guy, right? He has to be set to be an access port. So switch port mode access, again, we learned this last week, and switch port access VLAN 20 to put this PC into VLAN 20. Remember, the VLAN, the PC itself does not know it's in VLAN 20. The only reason it's in VLAN 20 is because that port right there, that port was configured as a VLAN 20 port. So this PC is now in VLAN 20. It has no idea that it's in VLAN 20. Remember, the tags are added by the switch. So here we have we have our default gateway and our configuration on our PC. Notice there's no configuration for VLAN on the PC itself. And then, so access VLAN 20 exit, go to the other interface, F01. F01 is this guy right here. And notice we have to set, first we have to set it to a trunk port and then bring it up by doing no shutdown and exit. Also note that they didn't add the command to switchboard to VLANs allowed. They didn't put that command in there. So any traffic is going to be transferred with the way they set it up here. And then switch 1 is similar to switch 2. Now they go to, now they're on R1. Note we are on R1. And we have to configure these sub interfaces on that port right there. So the router on a stick method requires sub interfaces to be configured for each routable VLAN. The sub interfaces must be configured to support VLANs using the encapsulation .1q VLAN ID, whatever the VLAN is. Although not required, it is customary to match the sub interface number with the VLAN number. So let me zoom in on this. So here are our configuration interface. And now notice we're on R1 and we're configuring G00. So all you do is add .10. Then you have to remember to type encapsulation. Now don't worry about spelling encapsulation. You can just type ENC tab. I'm pretty sure that works. If not, ENCA tab. And then you got to type .1q. There are two protocols. We only teach .1q. It is the interface that is equipment neutral. Cisco has its own encapsulation method that they don't teach now. They used to, and it made things that much more complicated because you had to remember both methods. Now you just have to remember encapsulation.1q10, and then give it an IP address, and then subnet, and then go to the next interface, G00.30. It's going to match the 30 network, encapsulation.30, and then give it an IP address in the 30 network, and then bring up the network. I remember when I went through the class, I got all that stuff down, but I forgot to bring up the interface and I lost points on that assignment or exam or whatever it was, but I never forgot since. So you have to bring up the interface. I do want to say that I don't remember what I had to say, so we'll just keep going. All right. Oh, I zoom in on that. Isn't that special? All right, so adding descriptions helps to reduce errors. In this configuration, the R1G0001 interface are configured for VLANs 1020 and 99. And I love the history method for creating your VLANs because what you do is you reuse the commands that you got to here. You'll get practice hitting the up arrow, right? So you got to do this one all straight up. So it's interface G0001.10 for the 10 network. Um, and here they added a description default gateway for the VLAN 10. Do we need that? No. Is it helpful? Yes. Encapsulation.1Q10, IP address, and then an address that's inside of the 10 network and the subnet, and then exit. Now, the next command is actually you don't have to type exit. You can just go right into the next command. So you could just type interface G001.20, and then now you can actually use the up arrow. So you already typed dot 110, right? So hit up 1, 2, 3, 4. You'll be back here, and then you'll be back here, and then you'll just change it to 20. And then the default gateway, you up arrow 4 times, and then you'll be on this line, and then you change the 10 to a 20. And then up arrow 4 times, and you'll be on this line over here, and then you just change the 10 to a 20. You get the idea, right? Same thing with the IP address, right? So by doing that, you can, once you get this one down, then these next two go really fast. You just got to remember to do them, right? And then they even put a description on the gateway. Now notice, all this is just a description, and it's trunk linked to S1. If you don't do any configuration of a trunk on the router, right? This is just a description saying this is a trunk link to S1 because it is a trunk link. It's carrying all of the VLAN traffic on it. It is a trunk link. There's just no trunk uh, configuration like we do on a switch. It's not the same configuration. You're doing sub interfaces. That's the trunk configuration, not saying interface mode trunk, right? That's not done on the switch, only on the, that's not done on the router, only on the switches. Okay, that's good. Remember to set the native VLAN, and how you set the native VLAN, it's the same configuration, encapsulation.1Q, what 10 or 99 or 1 or 100, whatever, right? And then you got to remember to put the word native afterwards, and then you give it an IP address and subnet mask, just like we did before. And here it is right here, .1Q 10, and they did that one, and then they did .199 native, and they only put this here to show, to make the VLAN 99 a native VLAN is you put the word native after it. That's how you do it, okay? And then don't forget to bring up the no shutdown. You're going to do a packet tracer on router on a stick and a lab as well. And then remember if you're doing the lab on real equipment in the computer lab in our classroom or at the ATC, make sure you look for previous VLAN information. And if you have VLAN information, then you erase your VLAN by either deleting the VLAN.dat, or you can clear the startup and you can clear the startup and the VLAN.dat file by just erasing NVRAM. Only do that on NetLab if it tells you to do that on NetLab. All right, now inter-VLAN routing using a layer 3 switch. Yay, layer 3 switches. I'm so excited. When I first saw this, because when I went through Cisco 1 and 2, I was like, give me the good stuff. I wanted the good stuff. I don't want to just keep dealing with these old routers and layer 2 switches. I wanted the good stuff. So when they added layer 3 switch to Cisco 2, I got really excited about that. I know. I'm a Cisco teacher, sorry. The modern method of performing inter-VLAN routing is to use layer 3 switches and switched virtual interfaces, SVIs. An SVI is a virtual interface that is configured on a layer 3 switch, as shown in the figure. A layer 3 switch can be also called a multi-layer switch, as it operates at layer 2 and layer 3 based on whatever the port is configured. So here, this port would be this would be configured as a layer 2 port, and then these a layer 3 port. So I'll show you the commands, and remember it's virtual, it doesn't exist, nothing's connected to it. Inter-VLAN SVIs are created the same way that the management VLAN interface is configured. The SVI is created for each VLAN that exists on the switch. Although virtual, the SVI performs the same functions for the VLAN as a router interface would. Specifically, it provides layer 3 processing for packets that are sent to or from all switch ports associated with the VLAN. The advantages. The following are advantages of layer 3 switches. They are much faster than router on a stick because everything is hardware switched and routed at the switch, the smart switch. There's no need for additional links from the switch to the router for routing. Layer 2 ether channels can be used as trunk links between switched to increase bandwidth. We learn about ether channel in a future chapter in this course. Latency is lower because data does not need to leave the switch in order to be routed to a different network. Think about it. It has to leave the switch, go to the router, and then come back from the router, and that takes time. With the SVIs on a smart switch, it is routed at the switch. They are more commonly deployed in campus LANs than routers, medium size. And then I created this slide just to show you what the negative is and its price. I just went to one online realtor and I did a search for layer 3 switch, and these are the prices. You know this. You can buy an unmanaged switch on any online site for $10, or you can buy a managed switch for not that much more, $100, a couple $100 maybe at the top end. Not talking about Cisco. Cisco obviously is going to be more than that. But these are layer 3 switches, and they're $3,000 and $4,000 and $5,000, $9,000, right, for the number of ports. So that is the disadvantage of having a layer 3 switch. All right. So inter-VLAN routing using the router on a stick method is simple to implement for a small to medium-sized organization. However, a large enterprise requires a faster, much more scalable method to provide inter-VLAN routing. Enterprise campus LANs use layer 3 switches to provide inter-VLAN routing. Layer 3 switches use hardware-based switching to achieve higher packet processing rates than routers. Layer 3 switches are also commonly implemented in enterprise distribution layer wiring closets. The capabilities of a layer 3 switch include the ability to do the following: route from one VLAN to another using multiple switched VLAN, virtual interfaces, SVIs. Convert a layer 2 switch port to a layer 3 interface, a router port, and I'll show you how to do that, I think, in the next slide. A router port is similar to the physical interfaces on a Cisco iOS router. To provide inter-VLAN router, layer 3 switches use SVIs. SVIs are configured using the same interface VLAN ID 102030 command used to create the management SVI on a layer 2 switch. A layer 3 SVI, remember the native, right? Management. A layer 3 SVI must be created for each of the routable VLANs. So it looks like this. So here's our, by the way, that is the symbol for a smart switch. Don't get confused. And when you see that fancy D1, D standing for a smart switch, we call it D1, not S1 anymore, right? And it's connected to two hosts on different VLANs, 10 and 20. And the layer 3 switch will provide inter-VLAN routing services to the two hosts. So PC1 will be able, well, PC1 was, oh yeah, PC1 would be able to talk to PC2 once this is configured properly. How do you do it? So you create the VLANs, and in the example, VLAN 10 and 20 are used. Create the SVI VLAN interfaces. The IP addresses configured will serve as the default gateway for hosts in the respective VLANs. Configure access ports. Assign the appropriate port. Now, once this is assign the appropriate port to the required VLAN. So these have to be configured as access ports, and they're set to VLAN 10 and 20, those two ports. Just like we did before, there's nothing different. We add the SVIs. That's what makes it different. And then you'll see what we do to the actual port to make it a routable port. Then you enable IP routing. You have to issue the IP routing global configuration command to allow traffic to be exchanged between VLANs 10 and 20. If you don't enable IP routing, then the switch will not act as a smart switch. You have to remember IP routing. Kind of like how we turn on IPv6 routing when we're dealing with IPv6. You're just turning it on. This command must be configured to enable inter-VLAN routing on a layer 3 switch for IPv4. Now, I made these slides from the slides in the actual NetAcad content. So if for some reason this is confusing to you, you can always go back to the content. You should be reviewing the content in NetAcad anyways to back up what I say, or even better, read it before you come to class. So here, the first step is we are going to set our, this is our network we're working with. We're going to have switch virtual interfaces on a smart switch that are going to be able to route VLAN 10 and 20. First thing we do is set our VLAN. So VLAN 10, we name it LAN 10. VLAN 20, we name it LAN 20, and then we exit out of that step. That's step 1. Step 2, we create the SVI LAN interfaces. So notice we're on D1, right? So interface VLAN 10, we're in the interface mode. We give it a description default gateway SVI for the 10 network. That's just a description. Then we give it an IP address, right? So IP address 192.168.10.1 for the 10 network. And then no shut. You got to remember to bring up those virtual interfaces. Otherwise, obviously, it won't work. Do the same thing for switch 2. So just like we did the management interface, giving this or a layer 2 switch an address to be able to access the switch remotely, that was the same command. Here we get out of, we're done with that. The third step, we have to go to configure the access ports. So interface gigabit 106, access port to PC1. That's this port right here. We haven't stopped the fact that we're still routing. Just like we did earlier with the router on a stick, we still have to set it up as an access port. So it's description, access port. Again, that's nice to have, not required. Then switch port mode access, we're saying that is an access port. It's going to one device. Yep. And then, so it's an access port, and then it is switch port access VLAN 10. So we're putting it in VLAN 10, putting that port in VLAN 10. We do the same thing on this side for VLAN 20, setting this to an access port with switch port mode access, and then switch port access VLAN 20. Give it a description as well, and then exit out of that. So now we have our access ports. And now we are going to enable IP routing. Remember, IP stands for IPv4, just like IPv6 routing. So IP routing means IPv4 routing. I've said that before. And that is the final step. And now we are able to communicate within our network. Now that switch can also talk to other switches. To enable routing on a layer 3 switch, a router port must be configured. A router port is created on a layer 3 switch by disabling the switch port feature on a layer 2 port with the no switch port interface configuration command. This converts the layer 2 port into a layer 3 interface. We're talking about this port right here. We are going to make that port a routable port, and the way we do that is we say no switch port, right? So switches by default, all of the ports are switches, and you have to make it a routable port. We're saying you're not a switch anymore. You're not going to act like a switch port anymore, and that makes it a routable port. Now that only works on smart switches, right? It has to be a layer 3 switch. You can't do that on a layer 2. It won't understand that command. Then the interface can be configured with an IPv4 configurable address to connect to a router or another layer switch port and then out to the internet. For VLANs to be reachable by other layer 3 devices, they must also be advertised using static and dynamic routing. Now, they are going to talk about OSPF here in a moment. OSPF is what you spend all of Cisco 3 working on. I want you to realize in Cisco 2, they just give you the commands to understand the commands. They don't explain OSPF. If you're really excited about learning about OSPF, you can go online to YouTube and you can find lots of videos about OSPF. Who knows? Maybe I'll have some videos when I make my Cisco 3 class videos here soon. All right, I don't have them yet. Routing scenario. So here we're going to continue. So in the figure, D1 layer 3 switch is now connected to R1. R1 and D1 are both on an open shortest path first OSPF routing protocol domain. These guys can talk to each other now because we're gonna configure OSPF on both sides. Assume Inter-VLAN has been successfully implemented. All of this has already been configured. The G1 interface of R1 has also been configured and enabled. We've given it an IP address and did the no switch port command. Additionally, R1 is using OSPF to advertise its networks. Ultimately, what a router does is it uses OSPF to advertise what it knows. So router 1 knows about the 20 network over here. So it's going to talk to the switch. It's going to say, hey, I know about the 20 network. And D1 says, hey, thanks for that information. And it's going to say, hey, I know about the 10 network. And it's going to say, router 1's going to say, oh, I don't know about that. Yeah, thanks, Pat. Send me that information. And it's a handshake. And you learn, like I said, you'll learn that later. So that now will work. OSPF routing configuration is covered in Cisco 3. In this module, OSPF configuration commands are given to you in all the activities and assessments. It is not required that you actually understand the configuration more than what I just told you when we're dealing with configuring OSPF on a layer 3 switch. So the routing configuration. So here we're going to interface G101, which is G101. We are right here. And we are going to give it a description, routed port link to R1. Then to turn it into a routable port, you say you're not a switch port. The easy way to think about this, if you get confused, is when you open a switch, when you take a switch out of a box, that switch acts like a switch. You can just plug PCs into it and it will just start talking. You plug 3 computer PCs into it, no configuration, it will start talking. So by default, a switch is set to switch port. I think I've even told you that before. So in order to take a switch that's set to be a switch, you need to make that a routed port. You need to say no switch port. You're not a switch port anymore. And by saying you're not a switch port anymore, you're making it a routed port. All right. Hopefully that helps you to remember that. that's required. Then give it an IP address, because now it's a routable port, so you have to give it an IP address in a subnet, and now you have to say no shut to bring that address up, bring that port up. And then you have to enable IP routing with the IP routing command. Then this is just advertising. This is configuring OSPF. You turn it on with router OSPF 10. Then you advertise the networks, and then Control Z just exits all the way back out to enable. You know how to do that by now. And then they want you to go ahead and verify that it's working by going to the IPv4 routing table with show IP route, and this is our routing table for IPv4, and you can see directly connected link networks and the links, the IP addresses that are connected to those networks. And then look at that, we got an O. An O, guess what? An O means you have an OSPF connection, and you have learned about the 20 network via the 10 next hop address, 10.10.10.1 next hop address, which is the exit interface of 1.0.1. So that's great. It's working. And then the other two are already connected. And then you can ping to make sure it worked. You're going to do a packet tracer. Actually, you're going to do a couple packet tracers. Only one packet tracer on this. The rest of them are in troubleshooting. Troubleshooting Inter-VLAN routing. Now, of course, we can't talk about all troubleshooting possibilities because it could be all sorts of issues. But what this part of this chapter module helps us with is understanding the concepts of when you should do what. When you should do, for example, if you're missing VLANs, you can do a show VLAN brief, and you can do show interfaces, or you can ping. To see if we'll ping a network, ping the 18, F18. Oh no, we lost 11 earlier. So ping F11, F011, and see if it responds. Remember, if it's missing, if actually that's a port that's missing, you still do the same thing. If you're missing the VLAN itself, well, to fix it, you need to create that VLAN again. If you expect to have a VLAN 20 and a VLAN 30, you need to recreate it. Ensure the host port is assigned to the correct VLAN. You got to make sure that if you want PC1 to be in VLAN 20, that the port on the switch is set to VLAN 20. If you have switch trunk port issues, ensure the trunks are configured properly using the show interface trunk. Ensure a port is a trunk port, and it's enabled by showing the running configuration. Switch access port issues, assign the correct VLAN to the access port. It doesn't help if you think a certain PC is a host is in VLAN 10 and you put it in VLAN 20, right? Ensure the port is an access port and it's enabled. Remember, access goes to host computers. Trunk goes to other switches. Host is incorrectly configured in the wrong subnet. Basically, that's just saying you didn't configure your PC correctly. And you can go to the PC to make sure it's in the right place by doing an IP config. Router configuration issues. Make sure all the sub interfaces are correctly configured, and make sure the router sub interface is assigned to a VLAN ID. And then they ping. Router on a stick configuration is complete after the switch trunk and the router sub interfaces have been configured. The configuration can be verified from the host, router, and the switch. From a host, verify connectivity to a host in another VLAN by using the ping command. If you can get there, great. If you can't, then use the IP config to check the IP address of make sure you have the right IP address for the host. Next, use the ping to verify connectivity with PC2 and S1 as shown. So they ping the other PC, and then they ping the switch by pinging the router interface. The SVI on the switch, and then that's all they do there. Here's a flow that might help. No connection, show VLAN, show MAC address table. Well, that's over here. No connection. So we've got a problem. We can't ping. So is the port in the correct VLAN? If the answer is no, well, assign the port to the correct VLAN. That's simple enough. If it is in the right, if the port is in the right VLAN, then check to make sure that the VLAN is present in the VLAN database. You can do show VLAN. You can show interfaces, show interface switch port. No, well, create the VLAN in the VLAN database, right? Add your VLAN database, and then yes, and then check, see if it works. If it is in the right, then you need to make sure all your cables are connected. So if you've got the ports connected and the VLANs properly configured, then you've got a disconnected cable someplace, probably. Now, if you have missing VLANs, an inter-VLAN connectivity issue could be caused by a missing VLAN. The VLAN could be missing if it was not created in the first place, or if it was accidentally deleted, or if it's not allowed on the trunk link. You got to remember the trunk link has to allow it to be passed. When a VLAN is deleted, any ports assigned to the VLAN become inactive. I mentioned that earlier. They remain associated with the VLAN, which is not there anymore, and so you can't do anything with that port until you recreate the VLAN by creating a new VLAN, or recreate the missing VLAN, or you can create the missing. Recreating the missing VLAN would automatically assign the host to it, so the ones that were missing will go back to the VLAN. Now you can use the show interfaces interface ID switch port command to verify the VLAN membership of a port. So now the only reason they have do here is because notice we're in global configuration, and that allows you to run commands. If I don't have to tell you Linux people that command, but do just lets you run a command that's you're not supposed to be able to run. Now you have to get it exactly right. You can't make mistakes but anyways, it'll just say it won't work. It won't tell you. It won't give you all the help that in the show in enable mode will. But anyways, do show interface, whatever port you're interested in, and switch port, and it gives you information. It tells you your access port, tells you the encapsulation, and it says that the VLAN 10 is inactive, so there is a problem. Now, VLAN router on a stick inter VLAN routing verification. In addition to using ping between devices, the following show commands can be used to verify and troubleshoot the router on a stick configuration. You can use show IP route, show IP interfaces brief, show interfaces, and show interfaces trunk. And we have slides that show each one of those. So this is show VLAN, and instead of just it's show VLAN, then whatever one you want to see, show VLAN name student, right? And then it tells you about the ports that are in the VLAN 20 for the student VLAN. It gives you additional information below. And here you can do a show VLAN summary, and it will tell you the number of VLANs, the VTP, how many were transferred using VTP, and if any extended VLANs were assigned. Here we show interfaces VLAN 20, and look at all that good information you can find out about VLAN, including VLAN 20 is up and the line protocol is down, and then you can read through and maybe find out why. IP addressing issues with VLANs. Common practice to associate a VLAN with an IP address. Different IP networks must communicate through a router. All devices within the VLAN must be part of the same IP network to communicate. So here, do they give you the answer? Yeah. In the figure, PC1 cannot communicate with the server, which is here, because it has a wrong IP address configuration. Notice you are in it's just in the wrong. I apologize. I'm trying to see what the problem was. Yeah, I thought it was more complex than it was. It's just a typo. Look, here 172.172.10.21. That's in. You would jump on the 10 network, but look, it's communicating with another address in the VLAN 10. But look, it's only 17. They forgot the 2, and typos will get you every time when it comes to an IP address, right? Good, you guys found it. In this example, PC4 cannot reach the web server. I'll give you a second. Let's just do this. I'll pause it, give you a second to look at it, and then we'll see if you guys found the answer. Okay, hopefully you found the problem. The problem is the port is, oops. Here it is. The show interfaces trunk on S3 F03 is an access port, right? You can't have an access port on a, well, the switches have access ports that go to host devices, but you can't have, you shouldn't have it configured as an access port here. This should be a trunk port here. So to configure it, config terminal interface F03 switchboard mode trunk, and that will fix that issue. All right, let's take a look at the next one. And in this case, PC5 cannot reach the student email server, and we have a problem. The problem is that the 20 network is not allowed. You need to allow the 20 network. Notice only the 10 and 99 are allowed. They forgot to allow the 20 network. And we can go to the next one. Trunking issues are usually associated with incorrect configuration. The most common type of trunk configuration issues or errors are the native VLAN mismatch. It poses a security risk and creates unintended results. And for example, one port is defined as native VLAN as 99 and the other one's 100. You just change one to match the other one, fixes the problem. Trunk mode mismatches causes loss of network connectivity. For example, one side of the trunk is configured as an access port, the other one's a trunk. Obviously, to fix that, you make the access port a trunk port on a switch going to another switch. Allowed VLANs on trunks causes unexpected traffic or no traffic to be sent over the trunk. Check the list of allowed VLANs and make sure that the VLANs that you have in the network are supported. If you're missing one, like VLAN 20 was just a moment ago, you add it. When a trunk problem is suspected, it is recommended to troubleshoot in the order shown above. And then they show us a nice flow diagram of how to troubleshoot this. I'll zoom in so you can see it better. So troubleshooting trunks. Native VLAN on local and peer ports match? If yes, well, let's say no. Change the native VLAN to matches, and then everything will work fine. If it's yes, trunk modes on local and peer ports compatible? If no, well, statically configure ports on both devices to trunk. That's that whole DTP thing. And then once you get that fixed, then it should work. And then the native, I guess I got to zoom out for this. In this example, the native VLAN should be VLAN 99. However, the output of the command identifies VLAN 2 as the native VLAN, and that is going to be a problem. Verifying trunk configuration. So here we have, let me zoom in and we can move down this. So here we have the interface with, they're configuring it. And then show interface. They're not they configured it. Okay, great. Now we are going to show interface F01 switch port, and we can see that it's mode trunk as was set here. That the encapsulation is .1Q, and that it is We didn't send any VLANs yet. So the native VLAN is 99, and tagging is enabled. There's no voice VLAN, and trunking is enabled all. So these look like everything you should have. Switch trunk port issues. Another issue for Inter-VLAN routing includes misconfiguring switch ports. In a legacy interface VLAN solution, this could be caused when the connected router port is not assigned to the correct VLAN. However, with the router on a stick solution, the most common cause is a misconfigured trunk port. Verify that the port connected to the router is correctly configured as a trunk link using the show interface trunk command. If the port is missing from the output, examine the configuration of the port with the show running config interface whatever command to see the one you're missing, to see how that port is configured. So here we have show interface trunk, and we can see that on S1, and we can see that FO1 is trunking and the native VLAN is 1. What's allowed is all, let's see, on the trunk on FO1 is all on the trunk. Allowed and active in management is 1, 10, 20, and 99. And then spanning tree, again, another thing that's in Cisco 3, I believe. Yeah, I think it's Cisco 3. At least it used to be. It might be in this class. I don't think so, though. I don't remember. We might cover it in this class. And then what's allowed in that site. Inter-VLAN routing using a layer 3 switch is simpler to configure than a router on a stick method. After the configuration is complete, the configuration can be verified by testing connectivity between the hosts. From a host, verify connectivity to a host in another VLAN using the ping command. It is a good idea to first verify the correct host IP address configuration using the ipconfig Windows host command. Next, verify the connectivity with PC2 using ping in Windows on the PC. The successful ping confirms your inter-VLAN routing is operational. Now, you could have problems with the sub interfaces if they've been not configured. So verify the sub interface status using the show IP interface brief command. Verify which VLANs each sub interface is connected to. To do so, the show interfaces command is useful, but it generates a lot or a great deal of additional unrequired information. The command output can be reduced using the iOS command filters. In this example, use include keyword to identify only lines containing the letters gig or 802.1q. And notice our show interfaces with a pipe to include gig or 802.1q. And here we have just the information that deals with the encapsulation mode. You're going to do a packet tracer on troubleshooting, a lab on troubleshooting, a packet tracing, and then the ultimate challenge and ultimate lab, where you have to wrap in a bunch of the stuff we've learned into these assignments. Those are pretty challenging, and you should be proud of yourself if you can ace, especially this packet tracer 4.5.1. It's challenging. You should be proud of yourself if you get it right the first time through. That is all I've got for Module 4, Inter-VLAN routing. I'm going to go ahead and stop sharing and bring you back to me. So hopefully you've learned some additional information about VLANs with router on a stick, and you get your first look at smart switching and how a smart switch can route traffic using a routable port. I highly recommend you take all these notes and write them down in your tech notebook. There's enough differences between what each device does and the two, actually, yeah, just the two configuration mode. You don't need to know about legacy mode, but make sure those commands are well identified in your tech notebook, and it'll help you with all the assignments and in future assignments as well. My name is Don LaFond, Professor Don, and I'm glad you came to class today. If you got any questions, in just a moment, I'll open up our live class for questions, a Q&A period. Again, if you're watching as a recording in our NetAcad classroom, ask in the help discussion forums. And if you're on YouTube, please ask questions below in the comments, and also like and subscribe to my videos so you can be notified when I make new videos. And like I said, I plan on making Cisco 3 presentations here. I have no idea when you're watching this, so I don't know how relative that is, but I will have Cisco 3 videos when I'm done making all these Cisco 1 and 2 videos. Anyways, it's been my pleasure. Thank you so much for coming to class, and I'll see you again in the next video. Thank you for coming. Bye now.